Greetings of the day. Today we are going to discuss the flexural test on a beam using both 2-point and 3-point loading methods. This practical aims to determine the flexural strength of the material and to compare how different loading conditions affect the bending behavior of the specimen. Experiment number 3. Flexural strength of concrete beam AIM. To determine the flexural strength of concrete beam, modulus of rupture, by using universal testing machine. Apparatus UTM. Concrete beam of size 15x 70 centimeters, when size of aggregate is less than 38 millimeters, or size 10x x 50 centimeters, when size of aggregate is less than 19 millimeters. Weighing balance, ruler scale. Reference: Indian Standard 516 1959, reaffirmed 2004, Method of Tests for Strength of Concrete. Indian Standard 456, 2000 Plain, and Reinforced Concrete Code of Practice. Theory: the flexural strength of concrete, also known as the modulus of rupture, FF, is a measure of an unreinforced concrete beam's ability to resist failure and bending. Significance: it is critical for designing pavements, slabs, and other structural elements where tensile stresses due to bending are predominant. Since concrete is weak in tension, its flexural strength is a key design parameter. Loading method. This test is typically performed using a 2-point loading system, also called 3rd-point loading. This method ensures a constant bending moment between the two loading points, inducing a pure flexural failure in that region. Failure: the beam fails in tension on the bottom face, soffit, within the constant moment zone. The failure is sudden and brittle. Formula: the modulus of rupture is calculated using the following formula from Indian Standard 516. For a greater than 13.3 centimeters, for 150 millimeters beam, FHA times L by B times D square. For a less than 13.3 centimeters but greater than 11 centimeters, FA 3 times P into A by 2 times B into D square, where for HH modulus of rupture, Newton per mm square or megapascal. P maximum load applied at failure, Newton. LE pay, supported span of the beam, millimeter. Standard is 500 millimeter for a 150 millimeter beam. BK width of the beam, millimeter. DU depth of the beam, millimeter. A distance between the line of fracture and the nearer support, millimeter, measured on the tension face. In this diagram, the specimen is supported at two ends, but loaded at two equal points, usually symmetrically placed. The bending moment is constant between the two loading points, producing pure bending, no shear in the central zone. Setup: 2 supports plus 2 equal loads at equal distances from the center. Formula for bending stress: stress is equal to 3PA divided by B into D square, where P shapes one of the applied loads, a GC distance between support and load point. 3-point loading, or a 3-point bending test. The specimen, usually a beam, is supported at two ends and loaded at the center with a single downward force. It produces maximum bending moment at the center and is used to determine flexural strength or modulus of rupture. Stress is equal to 3 by Toby square, where P load at fracture, LU span length, B width, D depth of beam. Procedure: measure the width, B, and depth, D, of the beam at the mid-span section to the nearest 0.2 millimeters. Record these values. 2. Examine the testing machine to ensure it is calibrated and functioning correctly. Place the beam in the testing machine symmetrically. The supported span, L, should be 500 millimeter. 3. The loading system must be a 2-point loading setup, where the load is applied equally at 2 points, each located at 1/3 of the span from the supports. 4. Apply the load without shock, and increase it continuously at a rate of 0.7 megapascal min, approx. 400 kilograms per min. 5. Continue loading until the specimen fails. Note the maximum load, P, at which the beam fractures. 6. Record the type of failure and the distance of the crack from the nearest support, A. The table in the image shows the results of flexural tests conducted under 2-point and 3-point loading conditions on different beam specimens. It lists key parameters like span length, the distance between the supports during the test, width, B, and depth, D cross-sectional dimensions of the beam specimen, maximum load, P, the highest load the specimen can withstand before failure, flexural strength, F, calculated using standard formulas depending on whether it is a 2-point or 3-point loading test. Cautions to be taken while performing experiment is: the beam must be placed centrally and symmetrically on the supports. The load must be applied without any impact and at a constant rate. The distance must be measured accurately after the test. And finally, we got the results. The average flexural strength of given specimen, He202 Newton per millimeter square,